Chapter 4, Lesson 1, Representing Relationships. In this video, we're going to talk about what different relationships are in math and how we can write them in different forms. We have three ways that we're going to write these relationships. And before we get started, we need to go ahead and get one piece of vocab, and that is linear equations. We've talked about this before when we talked about equations of lines, that a linear equation is an equation with a graph that is a straight line. We've talked many times about, we know how linear has the word line in it, so that's our clue that we're looking for a straight line. Let's look at just an example of representing relationships. We're going to talk about, here's a table. Can I turn it into an equation? How can I describe it in words? And then how can I use it to further progress and extend our thinking? So here we go. The total cost of tickets to the school play is shown in the table. We see that the number of tickets is represented by the variable t. And we're looking at 1 ticket, 2 tickets, 3 tickets, 4 tickets, and so on. On the right column, the total cost, which is in dollars, will be represented by C, and we have values there. We've talked many a times about what is our X and what is our Y, but in this case, we're using different variables. Our X is now going to be T, and our Y is going to be C. So let's first start by writing an equation for the total cost. When looking at this, we know that the total cost is going to be equal to 450 times T. And I know that because we know the price of 1 ticket. And if we wanted to, we could double check that we have the right equation by going in and testing it with, say, 2 tickets. We know that the cost C should be $9 if I take 450 and multiply it by 2. Well, we can check that. 450 times 2, 0, I get 10. 4 times 2 is 8, plus 1 is 9, so yes, $9. So we have our equation. Just wanted to double check to make sure that equation was true for everything that we do. Now, let's describe in words what's happening in this relationship. One of the things I want you to think about is our relationship increasing? Is it decreasing? So are our values going up, getting more, or are they coming down? Let's see. Well, in our relationship, as our number of tickets increase, so does our total cost. So we are going to write a complete sentence to describe that. We're going to say the total cost goes up. And let's go ahead and describe how it goes up. We see each time it is increasing by that 450. If you think back to when we were doing slope, we actually have that in our equation where that 450 next to our t or our x. So that's the value. We'll say 450. So the total cost goes up. I forgot a word. By 450 per ticket. So it's not a difficult sentence, but it's just a quick description of what is happening. This is something that you would already say or do when explaining it to a friend. So now we're just going to actually formally write it out. Now let's extend our thinking. Our table stops at 4. What I'm going to ask is that you use the equation to find the cost of 15 tickets. Well, let's think about how we could do that. When I have my equation, which was C equals 450 times T, we're now going to say that T, the number of tickets, is 15. So I'm going to go back and substitute or replace the T now with the 15 tickets. Notice that I put it in parentheses. That is because we are going to need to multiply to get our final cost. If we take $4.50 times 15, we will find that the total cost of 15 tickets is $67.50. And that's what we're doing. We're using the table to create an equation to represent this relationship. We're explaining in words what is going on, and we're using it to go one step further and find information we didn't already have. Now, you could next be asked to explain that in words. You could be asked to say in words that the cost of 15 tickets is $67.50. You could be asked to write that in words. But for right now, let's go ahead and move forward. So here are the steps that we're following. In order for us to be able to take the information given to us and create an equation, we need to first be able to find the slope. Next, we're actually going to use the slope that we find and plug it into the equation right there next to the x variable, or in our previous example, the t. Now, we're using equations of lines. That means we are using y equals mx plus b. So there may come a time where we're going to need to use a little bit of extra math to figure out what that b is. We'll talk more about that in the next example. And then in the very end, we set equal to the y variable, or a better way maybe to say it would be to write the function or equation, since I know we haven't talked about functions quite yet, with m and b. So we're going to be plugging in the m and the b. Let's take a look at an example with all of that. So this time, I don't have a table, but I have a graph. Here we're being asked to write an equation to find the number of miles ran y. So actually it tells me that y is going to be miles that I ran after any number of days x. So one thing to help us out real quick is that x is the number of days. That's going to be important because we're going to need to be able to remember that as we move forward, and that y is going to be miles. So let's go ahead and find slope. Before, we learned we could find slope by using y2 minus y1 over x2 minus x1. And we could pick any 2 points on our graph. I like to choose the smallest ones if possible. And we'll use this as x1, y1, and x2, y2, just to make it clear. So when I plug those in, I end up with 7 minus 3.5 over 2 minus 1. Now all I need to do is simplify. 7 minus 3.5 is 3.5. 2 minus 1 is 1. So my slope is simply 3.5. Now we're going to use that to figure out y equals mx plus b. So to start, let's do what it says and plug our m next to x. So it's going to say y equals 3.5 times x plus b. And now we're going to need to figure out how can I find that b. In order to find b, the y-intercept, I'm going to go ahead and pick one of my coordinates. So we're going to pick one. I again like to choose the smallest ones possible, but it might be easier to pick one that's got whole numbers. So maybe we pick this 2, 7. So we're going to use 2, 7. Now I'm going to go back and plug those in into their spots. To do that, I'm going to say, instead of y, I'm going to plug in 7 equals 3.5. Instead of times x, I'm going to say times 2 plus b. So let's go ahead and simplify this so that we can figure out what is that b. We're going to solve an equation. Well, I can find that 3.5 times 2 is 7. To get b by itself, I'm going to need to subtract 7 on each side and find that b is equal to 0. And that's going to be helpful as we move forward because we need the m and this b to finish up and make our equation. So to the last part. We are going to use y equals mx plus b. Only this time, we're going to plug in our numbers. Now we're only using the m and the b because we want to make a generic equation that can be used with any of the points on our graph. So we don't want to plug in any x or y. We want to just plug in our slope and our y-intercept. So our equation is y equals 3.5x plus 0. Now we want to make sure we simplify this one step further because I generally ask, do I need that plus 0 on the end? And generally, you guys tell me no. So we're going to go ahead and finish by writing the equation y equals 3.5 times x. And that is the equation that will represent the relationship in the graph. Now, we're going to need to hold on to that equation because we're going to go ahead and use it to answer two questions. Here are our two questions. Let's first, really quick, start by rewriting the equation so we have it in front of us. There was no point in writing it if we don't have it in front of us to use. So I want to know how many miles were ran after 2 weeks. Well, before we know that y equals miles and x equals number of days. And this is why it's going to be important. Because I need to change the 2 weeks into a number of days. 2 weeks is equal to 14 days. So let's plug that in and see what we get. We're going to use that x equals 14. So y equals 3.5 times 14 we can find when we multiply that together. 3.5 times 14 is 49. So in 2 weeks, 49 miles were ran. Now that statement I just said, that in 2 weeks you would run 49 miles, that is the final part to what's going on. Because now we're being asked to write in a sentence what this answer means. So we're going to write exactly as I said. In 2 weeks, you would run, or you would have ran 49 miles. Box in what parts are our answers. So yes, we are at a point where you guys are going to need to be able to write complete sentences to state what is going on. It could be to state what the equation represents. It could be to state what our solution means. Just be ready to make sure you write complete sentences. Now we're going to move on to an example I want you guys to try. Now I'm going to zoom this out so you can see all the questions. So here's what you're going to try. It says the number of trees saved by recycling paper is shown. So you're going to use that graph to write an equation to find the total number of trees that are saved for any number of tons of paper, X. So Y is number of trees, X is tons of paper. Next, you will use the equation to find how many trees could be saved if 500 tons of paper are recycled. Now, I do realize my error in spelling, but you understand what I'm asking. At this point, pause the video and work this out on your own. Then you may start the video back up and see what the solution looks like. So here is a fully worked out solution. Next to the graph, you can see where I worked out the slope using the first 2 points here and here. Then I plugged those in to y equals mx plus b so that I could find what b is equal to. So I used the second coordinate. That's where the 34 and the 2 came from. And when I solved that equation, I found that b is equal to 0. So I went and plugged in my slope and my y-intercept, simplified it down to say y equals 17x. And then to use the equation, I went and substituted the x for the 500 to figure out that if you recycle 500 tons of paper, you will have saved 8,500 trees.